Hello everyone, I'm so glad to meet you again with another interesting video. In this video we're going to learn about what is meant by planning poker and how it's going to help us in preparing the schedule. Many of the concepts in Agile are a little weird, at least for the beginners. Some people may not feel comfortable with concepts like servant leadership, and then we also have relative sizing, planning poker, self-organizing teams, velocity, story points, user stories, and the list goes on. So if you're a beginner, if you're going to learn concepts related to Agile planning, then planning poker is a must, because the first step in preparing a schedule is to estimate things. However, in predictive way of doing project management, we estimate things using absolute estimation techniques. For example, we estimate duration in terms of working hours or days or calendar weeks. However, in Agile, we don't do this. We use something called story points. And planning poker is an exercise that we perform in projects to estimate the sizes of the features or user stories using something called story points. And this is a relative estimation technique. So if you're new to planning poker, you're going to find this video very interesting. So please watch this video till the end and you will really find this video interesting and informative. So let's get started. Okay, first, before we begin the discussion, we need to understand why we need to estimate things. Alright, for obvious reason, if you want to know when your project will come to closure, when you can deliver an item or a work package to the customers or client, we must do scheduling. And to prepare the schedule, we have to come up with estimates. But one of the prerequisites you need to have to perform estimations is the requirements. If the requirements are available, we can easily make the estimates. For example, if you're organizing a dinner party, you know how many people are gonna come and attend the party, you know the menu, and you know the start time and end time of the dinner party, and you know the preferred food and so on. Now, if you know the requirements, it's easy for us to estimate things. However, in Agile projects, you may not know the requirements. We need to discover the requirements on the go. We will start the project with some of the requirements, and the remaining requirements need to be found as we progress. We complete the work, we do the demo, we seek feedback, and that's how we identify the remaining requirements, unknown requirements. So we'll start with something called a product backlog. You might be knowing what is a product backlog. A product backlog is an artifact. So in this document, we will capture all the features and functionalities we need to have in the product. It's a kind of a big to-do list. Okay, if you complete all the items in the product backlog, then we can say we are done with the project. Now, we know the features, what and all features and functionality that should be there part of the product, final product. However, we may not know all the requirements, the specifications. We might know some of them, let's say, 30 to 40% of the requirements, and the remaining requirements need to be discovered through experimentation or trial and error, or maybe by demonstrating the work to the client and seeking feedback and so on. So here we have a product backlog, and this product backlog is meant for a online banking software. Assume that you are developing a banking software. So here we have a list of features like the user authentication, account overview page, fund transfer, transaction history, and so on. So if you complete all the items listed in this product backlog, we can say we are done with the project. Now the question is, you could see that here we have the IDs of the items. Here we have the items, their names, description, and here we have the types, whether they are features or bug fixes or risk responses, the type of item. Alright, some items are functionalities and features, some items are bug fixes, some items are related to issue fix and risk responses. And this column is meant for size. So we do not have the sizes now. We have done with the initial project, the product visioning process, and we listed down all the product backlog items, that is the functionalities and features that should be there in the final product. Now, to find out how much time we need to complete all these items, how much time we need to finish and deliver all this item to the client, and when each of this item can be completed. Maybe let's say item number 9 can be done in calendar week 5. Item number 13 will be done in calendar week, let's say 12. So you need to find this. So this is about scheduling. So to prepare the schedule, first we need to estimate the items in the product backlog. However, as I already told you, if you want to estimate something, we need to know the requirements. Unfortunately, in Agile projects, the requirement uncertainty level will be greater. So what shall we do? Can we proceed without doing estimations? No, that's not possible. Without estimations, you cannot create the schedule. So what shall we do? Well, of course, to produce absolute estimations, like how many hours or how many working days you're going to take to complete each of this item. For that, you need the requirements. But if you want to go for relative sizing, you don't need to know all the requirements in the beginning. We're going to compare each feature with the other feature and relatively size them. For example, feature A is 2 times smaller than feature B, and so on. Now, to understand this relative sizing concept, I'm going to give you an example. Let's say you need to estimate age of some people. Okay, here we have a family. We have son, father, and grandmother. And here we already have their ages. Son is of 6 years age, and father is of 37 years old, and grandmother is of 62 years old. Okay, this is my son's age, my mother's age, and my age. Now, you don't know this column. This column is hidden for you. So you're going to estimate and find out what is the age of the son, father, and grandmother. So you're going to do absolute estimation. You know some details about the father, son, and the grandmother. For example, you know which class the son is studying. You know the date of birth of the father. You know the biology of these individuals, like their aging in terms of biology, their bone structure, their body maturity, and you do some medical analysis and find out the aging of the liver, the heart, and the arteries, and so on. So you use some data. You have those data or information with you. These are called requirements. Now, with these requirements, you're going to figure out the age of the son, father, and the grandmother. So we do that, and we found that, okay, son is of 5 years old because he's in kindergarten, upper kindergarten, okay. And you know the age of the father by knowing when the father did his college. And you also know that one of the colleague who is working with him in the office is of same age. So you're referring to his age, and you are using that person's age, his colleague's age, to gauge the age of the father. And you do the same with the grandmother. You have some details with you, so like the date of birth, or you got a report from the doctor about the body condition of the grandmother, the age of the heart and the liver, and so on. So you use all this information to gauge the age of the grandmother. So you found it's 5 years for the son, 35 years for the father, and 62 years for the grandmother. Of course, because estimations are guesswork, we give accuracy. If you're very confident with some numbers, you put very less accuracy percentage. In this case of father, you came up with plus or minus 5%. When it comes to the son, you came up with 10% accuracy. This means you are very sure about the age of the father, but when it comes to son's age, you are kind of little doubtful. That's why you kept the accuracy greater. Now, if you see these numbers, these are very close to the real age of the father, son, and the grandmother. And we are using the unit years. So if you say year, a year is of 365 days, right? This is global. Everybody in the world knows a year is made of 365 days. Now, this is a standard unit. But to come up with this sort of numbers, we needed some information, details, and some requirements. What if you do not have all these requirements or enough requirements to do the estimations? Then you can go for something called relative sizing. So you are just comparing the son's age with the father's age with the grandmother's age, and the grandmother's age with the son's age. Okay, so now you found that son age should be of X. All right, and you're saying so son's age would be the smallest among all the three, isn't it? So you take son's age and you say father should be at least 5 to 6 times of son's age, and grandmother should be at least 11 to 12 times of son's age. So what we are doing here is we are doing relative sizing. We are not trying to estimate the age of son, father, and grandmother using absolute numbers, that is years, like 5 years, 35 years, 62 years. Instead, we are doing relative sizing. We take son's age as the measurement unit here. We don't know still what is the age of the son, but we are saying father should be at least 5 to 6 times of son's age, and grandmother should be minimum 11 to 9 times of son's age. So we take, instead of year, we took son's age as the unit of measure. So here you could see in this column, 1 time of son's age is son's age, and 6 times of son's age will be father's age, and 10 times of son's age will be approximately grandmother's age. Now, remember here, you cannot decide the absolute numbers with relative sizing. For example, if you say Ahmed is the father and his age is 5 times of son's age or 6 times of son's age. Now my son's age could be 6, and so my age could be 36. Or there's another possibility, my son's age could be 10 and my age could be 60, right? And there's also another possibility, my son's age could be 3 and my age could be 15. So we don't know the absolute numbers. We're just saying Ahmed's son and Ahmed's age is 6 times of his son's age. That's it. All right, so that's about relative sizing. All right, now let's move forward and understand more about this technique. So here, let me clean up the board. Okay, here you could see that the son's age is our unit of measure, right? This is a summary. It's not a standard unit like year or kilometer or dollar value and etc. So we say we're going to use son's age as the measure of unit, but this is local to this list. In this list, son's age is the smallest number, and we're going to do relative sizing of all other ages, all other people in this list, their ages, using son's age. And that's why we call this as not a standard unit. Kilometers, years, or standard units, they are comparable. You have some estimations in your project, you can compare those numbers with estimations in another project. But in this case, the unit what we are using is son's age, and that's not a standard unit. This unit is local to this list, to this project. All right. In absolute estimate, we have used years as the unit, and this is a standard unit. So as I told you, if you're using years or kilometers or dollar value, these are comparable. These are universal units, okay? And we use them only in absolute estimation, not in relative sizing. So son, father, grandmother are features or functionality to be delivered in the project context. So if you take this example and relate it to an actual project, the functionalities and features we have in the product backlog are synonymous to son, father, and grandmother. Okay. Now let's understand this relativizing in detail. Let's say you have a product backlog. We are going to develop a banking software, and we listed there's going to be this 6-7 features. View account summary, download bank statement, money transfer, cyber security, mobile notification, secure login, support, customer support system, and so on. So in the final website, we need to have all these features and functionalities. Okay. Now we first find out who is the son, because we take the smallest feature in the list and we use that feature to do relativizing of the remaining other features in the list. So let's find out which is the smallest feature. Let's take secure login as the smallest feature. Okay, let's assume. So we're gonna set something called story point. A story point is same as the sun sage, because in Agile we call these features as user stories. I have explained about user stories and how we create user stories, what is the connection between a user story and a feature. In another video, I have provided the link in the description. So if you want to learn more about user stories, you can refer to the link. Now, for the current discussion, let's assume or you treat functionalities and features you see in the list can also be called as user stories. Okay. Now, let's say this is the smallest user story, secure login. All right. And because we're going to use a unit to size user stories, we call them as story points. Okay. So let's say this is the smallest feature similar to sun's age. So I'm going to give one story point to this feature. Now I'm comparing this with other features, and I'm finding that cyber security is 3 times of secure login. So I'm going to give 3 story points to this. Okay, story points are virtual units and they are not global standards. Remember, they're local to the project. In this case, secure login is the smallest feature, and so we are assigning 1 story point to this. Now, comparing other features with secure login, we're gonna size them. So after giving 3 story points to cyber security, the message is cyber security is 3 times the size of secure login, or the amount of time you're gonna take to build cyber security. It's going to be 3 times of the time you're going to take to build a secure login feature. Then let's talk about this feature, mobile notification. This is somewhere between cyber security and mobile secure login. So it's 2 times of secure login. And download bank statement is of, let's say, 5 story points. All right. This means download bank statement is going to take 5 times of the time. 5 times of the time you need to build secure login. Or in other words, the time needed to build these 2 features, cyber security and mobile notification, will be equal to the time, approximately the time needed to build download bank statement feature. Clear? Because 3 plus 2, you get 5. And here you already have 5. So you need X amount of time to build these 2 features. With the same X amount of time, you can build this feature as well. Alright, now let's talk about view account summary. Again, we feel that it's 3 times of secure login feature, and money transfer is a very big feature. So it's 8 times of secure login feature. Okay, and how about support, customer support system? Let's give maybe 2 story points. Now you see we sized all the features or user stories in this list by first identifying the smallest feature in the list and assigning 1 story point to it, and we use that as our unit of measure to size the remaining features in the list. So if you say download bank statement is of 5 story point, this means this feature download bank statement is 5 times bigger than secure login. And the same with the money transfer feature. So money transfer feature is going to take 8 times more time needed to build secure login feature. But so far we don't know how much time it's going to take for us to build the secure login feature. It could be 5 hours, it could be 20 hours. Let's say to build the secure login feature, when we implement this feature, we might take 5 hours. Okay. Now this means approximately you need 5 times of 5 hours to build download bank statement. If this is going to take 50 hours, then this is going to take 5 times of 50 hours. Okay, that is 250 hours. So that's how we have to relate the relative sizing of features to the actual time they're going to take. But at the moment we know only one thing: secure login feature. If you compare the money transfer and secure login feature, money transfer feature is 8 times bigger than secure login feature. But we don't know how much time we're going to take to build the secure login feature. And so we cannot tell the absolute number, that is absolute estimate for the money transfer feature or the other features in the list. So I hope you got some idea about how we do relative sizing. So to do relative sizing, first you need to find out the smallest feature, or sometimes some people will first find out the smallest feature and the biggest feature. When we say biggest feature and the smallest feature, we are thinking about their physical size, how many lines of code we need to write. For example, if you are writing a software, the features are software features. We need to think about how many lines of code needed to build each feature and their complexity. Lines of code alone won't help us to understand how big a feature is. We also need to think about the complexity of the features. For example, if you want to write a program that has to solve pseudocode, or you are developing an AI algorithm, well, these codes though may not have so many lines, they're very intense, very difficult to develop. Let's say you are implementing a program that's going to pull some data from a database and display it in the website. This is a very simple code. Though you might write 50-60 lines of code, we can do this coding, develop this feature in a single day. So lines of code alone won't help us to size the magnitude of a feature. We need to think about the lines of code, how complex that feature is, the amount of risk involved in implementing that feature, and so on. Okay, so story points are used to size features based on their complexity, their lines of code, their risk factor, and so on. Okay, now after doing this sizing, now we found that, well, for this item we size this item with 3 story points, and this item with 5 story points, and this item with 8 story points, and this item with 3 story points, and this with 2, 1, and 2. Boom, we got all the sizes. Okay, this is about relative sizing of the features in the product backlog. Now, how to size this number? Can I do it all by myself, or can I use any number I want, or should I need to do this as a team? You have so many questions in your mind, right? So sizing the features using story points is all about planning poker. So we're going to talk about how to do this, how to play planning poker exercise. So planning poker was described first by James Grenning in 2002 and then popularized by Mike Horn in 2006, not very long back. And we use story points to size the features because we call features as user stories in Agile. So the story points are the units we're going to use to size the features in the product backlog, and we're going to of course use relative sizing. Okay, these are not global standard units like hours or kilometers or miles. Keep this in mind. Okay, so the other 2 points listed here are about the same. Story points are relative measure. They are not standard units. They are not universal, baselines. And so estimations done using story points in one product backlog in a particular feature must not be compared with estimations done in another project. Maybe because in that project the smallest feature could be bigger than your smallest feature in your product backlog. Clear? And that's why we should not compare the estimations done in one project with estimations done in other projects using planning poker exercise or using story points. Now, to do planning poker exercise, we need 4 prerequisites. First, we need to have a product backlog with user stories that need to be estimated. Of course, that's the first thing. Second thing is we need a pack of cards, deck of cards we need to use to size the features. I will show this in a moment. And third thing is you need an agile team. You need the product owner, the Scrum Master, and the development team. When we say development team, we are talking about the team members who are going to perform the work. If it's a software project, the developer, the code design, the designer, the integrator, the tester, everybody come together to form the development team. And of course, sizing features using story points by playing planning poker exercise, it's a teamwork. It's a group activity. Okay, so we need teamwork to successfully complete planning poker exercise. Okay, here we have a sample planning poker card deck. Well, you could see that you have numbers like 1, 2, 3, 5, 8, 13, 20, 40, 100, and then infinity, question mark, and pi. You might think why we don't see a linear sequence here. When it comes to sizing features, we prefer non-linear sequence than linear sequences, number sequences. There's a reason for this. I will explain this in a moment. And the number sequence, what you see here, is a Fibonacci sequence. To be precise, it's a modified Fibonacci sequence. We will talk about all these things in some time. But if you first look at the numbers, you see 1, 2, 3, 5, 8. So these are, sizes we use to size the features. Okay. And then you see here 13, 20, 40. And these are sizes used to size features which are really big in nature. And we call them as themes or epics. Okay. And 100 is also meant for epic. Infinity means this feature is so big and there's no point in sizing this feature. And you see this one, question mark. This means if someone is not clear with what size they have to provide or come up with for a feature, they will issue question mark. All right, they will show this card, question mark. I'm not clear, I'm perplexed, I don't know what size I have to give, I need more details. Pi means it has nothing to do with 3.14 or 180 degree. Here pi means American pie. I'm famished, I'm hungry, we're playing this game for a very long time, I'm so tired. So let's take a break. Alright, so that's about pi. Now, every team member will receive a card deck. So as I told you, this is a group activity. Every team member will receive a card deck. For example, let's say you have 5 team members or 9 team members in your project or 7 team members in your project. All of them will receive a entire card deck. Okay, all the numbers cards will be with them, and the product owner will explain the features to the user stories to the team members, and then the team members will size the user stories by playing the cards. Okay, we'll learn about the workflow in some time, but as I already told you, these sizes are used to say how big a feature is in terms of number of lines of code need to be done, or the complexity of the work, how difficult to implement something. So based on this, we set the numbers. Okay, and always remember, story points are not absolute estimates, they are relative. Now, why we are using Fibonacci sequence? Well, Fibonacci sequence is a nonlinear sequence, and there's a reason for this. First of all, maybe most of you might be knowing what is a Fibonacci sequence. So first we need to write down the first two natural numbers, let's say 1 and 2, and then we add up these two numbers to get the third number, 3. And then we add again the last two numbers, 2 and 3, we get 5. Again we add the last two numbers, we get 8. Again we'll add the last two numbers, we get 13. So like this we continue. This is all about a Fibonacci sequence, and this is a non-linear sequence. Why we need to prefer a non-linear sequence instead of a linear sequence? So I will demonstrate this in a moment. Well, if a feature is getting bigger and bigger, the level of uncertainty or unknown inside that feature will also be greater. So we should not try to be very precise with the numbers, the sizes of the bigger features. All right, maybe with the smaller features, precision is okay. If you take a smaller feature, there will be less complexity, there will be less uncertainty. So you can come up with precise numbers. So for smaller features, we're going to use smaller numbers like 1, 2, 3, 5, and so on. For bigger features, we use numbers like 20, 40, 100, and so on. If you have so many options with you, like for example, if you take 100, you also have 90, 110, people will start doing a lot of discussion which number we need to provide. This is unnecessary. Okay, so here I provided a linear sequence. Let's say you are using the multiples of 10, 20, 30, 40, 50, 60, 70, 80, and 100. People will comfortably use these numbers like 10, 20, 30 because they are meant for small size features. But as we start sizing bigger size features, you are providing so many options. Let's say a feature is of 8 times of the smallest feature. So one of your team member will say this is of 80 story points. The other team member will say no, it's 70, no, it's 95. All right, why this confusion? Because you provided them so many options. Well, how about this one? So you have 10, 20, 30, and then you do not have 40 in the list. You have 50, and then you don't have 60, 70, directly you have 80, and then you do not have 90, 100, you directly have 120. Now if you give this sequence, people have no trouble in sizing big size features. For example, if they want to size a feature with 50, they clearly know that the smallest number close to 50 is 30, and the next biggest number is 80. They don't have 40, 60, 70, and so on. So they will comfortably size the numbers. So as the size of a feature gets bigger, we should stay away from being precise with our sizing. It's not needed. We just need to do approximation, because features which are big in size will have a lot of uncertainty and solution complexity inside them. So we need to be practical. We need to size them approximately. Don't try to be precise. All right. So that's why we don't prefer Fibonacci. We don't prefer linear sequences. We prefer non-linear sequences in sizing the features. So if you take a Fibonacci sequence, there's a normal Fibonacci sequence 1, 2, 3, 5, 8, 13, 21, 34, and so on. And you could see that after a level, like after 13, you get 21, 34, 55. These are odd numbers. We want to use some round, neat numbers, and that's why people created modified Fibonacci sequence. So same as Fibonacci sequence, but after 13, instead of 21, we get 20. Instead of getting 34, we have 40. Okay, or 89, we have 100. So this is called as modified Fibonacci sequence. Most of the organizations prefer modified Fibonacci sequence. You can also use normal Fibonacci sequence or powers of 2. 2 to the power 1, 2 to the power 2, 2 to the power 3. So you get 1, 2, 4, 8, 16, 32, 64, 20, 128 and so on. Okay. So our favorite number sequence is this one. Most of the projects prefer modified Fibonacci sequence for planning poker exercise. I hope you understood why we need to use Fibonacci sequence or why we prefer nonlinear sequence over linear sequences, isn't it? Now let's understand the workflow, how planning poker exercise is conducted. Okay, so this is the workflow. First, we have to assemble the team, and the product owner should explain the team members about the features. Each and every feature need to be explained to the team members. So the product owner will first take the first item in the product backlog, the first feature or the user story, and explain this to the team members. And then before sizing the feature, every team member will ask their questions and doubts. All right. And the product owner should clarify the doubts and questions of the team members. And once all the questions and doubts are addressed, then once the team members are ready, we will ask them to, give them some time to select the size. Everybody will have a set of cards with them, so they have to think which size would be appropriate, correct for this feature. And it's up to them. They don't have to discuss with other team members until they play the cards. So everybody will think about what size they have to provide for this feature. So they will think about what the product owner explained to them. They will think about their assumptions about this feature, complexity of this feature, and then finalize the size. They have all the cards with them, right from 1, 2, 3, 5, 8, 13, 20, 40. So they will think on their own and decide, okay, according to me, this size would be the right size for this feature. They don't have to discuss with anybody, the other team members. So it's their own decision. And once everyone is ready, the Scrum Master will ask all of them to place a card on the table and flip them at the same time. Now, why we need to flip it at the same time? Because we don't want to influence others' opinion with ours. Let's say you have a senior senior architect in your team. You are a junior. You size this feature with 5 story points or 8 story points. But the subject matter expert size this feature with 2 story points. Then you might think, oh my God, the senior person, he herself sized this feature with 2 story points. I think I need to change my number. I think I'm coming up with a very big size. Well, how do you know you are wrong? Maybe you might know something which even the subject matter expert is not aware of. So we need to discuss about this after playing the cards. Okay. So till we play the card, nobody knows what size each team member is coming up with. After we play the cards, we flip the card at the same time, and then we see the numbers sizes provided by all the team members. Now, that's about the first 2 steps. The product owner will first explain the features, clarify the doubts to the team members, and then the team members will take some time and play the cards, and we all flip the cards. If all of them came up with same size, let's say all came up with 5 story points. This is very uncommon, but let's say you have 5 team members or 8 team members, all of them came up with 5 story points to a feature. Then we have reached consensus around this number 5. So we will put this number as the size of this feature inside the product backlog. We document inside the product backlog, and then we go to the next feature and repeat the whole process. In case if people came up with different sizes, that's how things will go. Let's say out of 5 team members, 3 team members came up with 5 story points. All right. And 1 team member came up with 13 story points. And 1 team member came up with, let's say, 2 story points. Well, we have outliers here, right? 13 and 2. These are extreme cases. Now we need to talk to the people. The team members should discuss. We have to check with these two people who came up with 13 and 2 story points. Hey guys, why you feel that this feature is so big? And for the other person, we need to ask this question, why you feel this feature is so small? They will come up with some explanation which we may not be aware of. For example, the person who sized this feature with only 2 story points might say, hey guys, don't you know we implemented a similar feature in the past, and we can reuse the code, and so we don't have to implement this code from the scratch. Okay, we were not aware of this. Another team member might say, you know what, we have to do a very long regression test. This will go on for, let's say, 2 weeks, and I think you guys are underestimating this test. Yeah, it's a valid point. So this discussion is what important. When we don't reach consensus around a number, we go for discussion. Remember, this is where the value addition is happening. During this discussion, the team members learn from each other. This is where we validate their assumptions we used to size a feature, and we learn from each other. This is all about materializing the benefit of collective wisdom. If you work as a team, you might know something which I am not aware of, and I might know something which you might not aware of. When we work together, we find out the unknown things and learn from each other. This will enable us to make better decisions. Especially in this case, you can come up with a very good, more appropriate sizes for the product backlog items. So after this discussion, we will play the cards one more time. The team members will place their cards, flip them at the same time, and this time again, let's say if you're not able to reach consensus around the number 5 or 13 or 2, we will play one more time. In real life, hardly we will take 3 iterations. So we will reach an agreement, we will reach consensus at least in the 3rd round of discussion. Okay, if it's not happening, then the Scrum Master should facilitate the team members to reach consensus and move on to the next feature. All right, so that's how we play planning poker. I hope you understood the workflow. Remember, the discussion what happens after playing the cards, it's what important. Now there are some pointers, attributes about planning poker exercise. First one is people who do the work collectively provides estimates. We are talking about the team members. The product owner and the Scrum Master do not provide estimates. The product owner will only explain about the features and functionalities, clarifies the doubts, questions of the team members, and the Scrum Master will only do the facilitation. So the Scrum Master should not engage in sizing the feature. The same with the product owner. It's only it's the job of the team members who are going to perform the work, and no individual is empowered to finalize the size of the team. Finalize the size of a feature. It's a teamwork. They have to work together, discuss, reach consensus, and finalize the size. Okay, and all team members should participate. We should not ignore a team member. We should not call only selected team members for the planning poker exercise. You know the reason, because the discussion is what going to help us to learn and validate our assumptions and come up with more reliable estimates, sizes, okay, story points. So that's about the planning poker exercise, how we do this exercise. Now, after you're done with the exercise, we know that we will size all the we will enter all the sizes we finalized during the planning poker exercise, and we put them inside the inside this column, inside the product backlog. Okay, so that's about how we play planning poker. And in case if you're not having a co-located team, so if you want to play cards, you can create these cards on your own, or you can purchase them from Amazon or any other e-shopping platforms. You can also consider using online platforms for playing planning poker exercise. In case if your team is a distributed team, let's say your team members are geographically distributed, then you can use online planning poker tools. There are many tools available. So I will show you a small demo now. Okay, if you want to play planning poker online, then you can search for planning poker online on Google. You get many free tools. I like this one, Scrum Poker Online. You can use other links as well, websites as well. Most of the features will work for free, so you don't have to go for the paid version. Okay, so once you land up on this page, you can go for create a instant room. Click on this, and before that we need to do sign up. I'm doing that. I'm going to use my Google account to do the sign up. Once your sign up is complete, you will get this a panel. You could see some options by default selected. You see the sizes. Okay, question mark, you know what is meant by question mark, 1, 2, 3, 5, 8, 13, 20. So here we see the modified Fibonacci sequence. You also see 0.5. 0.5 means very small feature, smaller than one story point. Okay, half of one story point. You also get number 0. This means free lunch. Sometimes a product owner will ask the team members to do a very small work for no charge. They don't want to include this activity as part of their velocity calculation. Again, if you want to learn about velocity, I prepared an excellent video on velocity. It's in the description. Watch it. So 0 means free lunch. Okay, you want your team members to do something for free, a very small activity or work, then you can go for 0, size 0. COF means pie, coffee, I'm tired, I need a break. Question mark, I'm not clear, I don't know what size I should come up with. Alright, so these features, these options will not be enabled, and still we are fine. They won't be enabled for free version. So now you can save this one. If you want to add new numbers or add new sizes or modify the existing sizes, you can do that. Once you save this content, you get the room ID. You can either share this with your team members, or the link or the number. People can go to their to this website in their browser and type in this room number. Okay, now I'm gonna go to this room and play the cards. All right, simple. Now everybody should have this open in their desktop or on their screen laptop, and you all should be in a conference call, preferably video conference call. The product owner will explain the feature to the team members, and once the discussion is over, we will give some time for the team members to play their cards. So let's say I'm one of the team member. I'm gonna think about this feature, and I'm convinced that this feature is of 8 story points. Okay, so like this, every other team member will go for playing the cards. Now we didn't show the cards. Once everyone is done, you can confirm with the team members. Once everyone confirmed you that yes, they all done with the playing the cards, they came up with the number sizes. Now you have to click on show. So when you click show, you see it's my name here, and I came up with it. Likewise, you will be able to see the sizes provided by the other team members, and then we can have a discussion on this to reach consensus and finalize the number and move forward to the next feature and repeat the whole exercise. Okay, so that's how we do planning poker exercise in a distributed or virtual team environment. Fine, let's go back to the slides. Okay, so we have sized all the features. Now here we have a summary of some key pointers or important pointers you need to know or remember about planning poker. Before we discuss about these points, I request you to give a like, a thumbs up to this video if you really find this video useful. People like us, content creators, put in so much of time and effort to prepare useful videos like this, educational contents like this, and your support is much appreciated. It costs you nothing to give me a thumbs up. So if you really like this video, give me a thumbs up. Also, you can subscribe to my channel because I regularly come up with a lot of learning materials related to project management. So in this slide, we have some useful attributes or pointers you need to know about planning poker. First, planning poker is a participatory decision-making technique. To be specific, it's a voting technique. All right, this is why we bring in everybody, every team member, and size a feature. We discuss, reach consensus. So it's a participatory decision-making technique. Second, anonymity. When we say anonymity, until we show the card, nobody knows what size we came up with, and this is good. This will avoid people getting influenced by the big people, that is the senior folks, the highly paid person, the highest paid person in the room, and so on. How do you know that a junior doesn't have a valid reason to say a feature is small or bigger, to be different from the other folks? We need to first know the reason. If the reason is valid, we learn from that person. Otherwise, we educate that person. Either way, it's beneficial for us and for the team. Third, a facilitator is needed. So yes, here we need a facilitator, that's the Scrum Master, and the product owner should provide the details about the features, clarifies the doubts of the team members before they size the feature. All team members should participate. We should never ignore anyone. All team members should participate in the planning poker exercise. And roughly we do this around about 1 hour to 3 hours duration max. Especially the first planning poker exercise will take many hours, like 2 to 3 hours of time. And after we start the project, we conduct planning poker exercise frequently, periodically, as part of product backlog grooming exercise. We might do this exercise before we start an iteration or a sprint, or in the middle of an iteration or a sprint, we can conduct planning poker exercise, which will be done as part of the product backlog grooming exercise. And we come up with sizes, and then we change them in later when we play planning poker based on our learnings. The more we do, more work we do, more we learn about the features and functionality. So we will keep refining these numbers throughout the project. All right, and we should never take average of the proposed story points. We should only reach an agreement for a particular number. Let's say someone is coming with 5, another one is coming up with 8, another one with 13. You cannot take an average, simple average. This is forbidden. You either go with 5 or 8 or 13. Also, we should use sizes only which are available in the card deck. 4 is not there, so you should not size a feature with 4 or 7. Okay. And planning poker is a quick and more enjoyable way to size and estimate features. So that's pretty much everything you need to know about planning poker. And if you're planning to take PMP certification at GAN Scholar, we offer excellent project management training for a very affordable pricing. And the best part is the first 10 hours of the training is for free. You can attend these demo classes and enjoy the classes. If you find the classes helpful and effective, you can continue with us by paying the training fee. I have provided the link to enroll in our bootcamp in the description, so please check it out. With that, we're done with this video. I will meet you again with another interesting video. Thank you so much and happy learning.